Welcome back. This is the solution video for this packet, a diagnostic test, and we're going to go over question 8, 9, and 10. So it should look something like this. Now the first question I see here starts out a cell phone. So a cell phone company wants to know how happy the customers are with their service. The company sent a text message survey to every customer's phone. So right now I'm feeling good. Everybody got this survey, no problems. However, out of the 100,000 customers, only 42,000 replied. Uh-oh. Bells and whistles should be going off. I'm thinking to myself, something's wrong with this design. So I'm going to label this a design question. And this is where we started the chapter, in design. Because if our study or experiment or our survey is not designed properly, then the data is bad. So let's take a look. Based on this, they concluded they're highly satisfied. But hold on a minute. All they can really conclude is that people that decided to respond were satisfied. They can't make an inference about all the people that did not respond. So, interesting. There was a whole bunch of people who didn't respond, and that looks exactly like question C, non-response bias. So that's probably my answer. I don't really need to do some math, but I could if I wanted. Out of 100,000 people, 42,000 responded, which means 58,000 did not respond. That's a whole lot of people. So you really don't know the opinions of this many people. Therefore, we can't make an inference about the population, and this is why. Next question. Question number 9. For employees of a large company, the correlation between X and Y is found to be R equal 0.74. So I'm just going to circle that. That's the first thing I'm going to do. The correlation between X and Y is R 0.74. So it looks like a positive correlation between those two values. What would be the correlation if Y was X and X was Y? So it appears as if they're flipping what X and Y would be. Remember what R is. So R tells us how close are the dots to the line. So if I made a scatter plot of my two quantitative variables, dot, 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 it looks like it would be going positive. So that's what I've got right there. I just made a quick sketch of a scatter plot. I know it's going positive because R is positive. Now, if I flip-flop X and Y, the amount that the dots are close to the line would be exactly the same. So I can kind of flip my paper over, and I can kind of actually think about what that might look like. I flipped X and Y. You can also kind of do it that way. It's kind of hard to see with the camera, but see, I still have the dots, and they're still just as close to the line as they were to begin with. So that should be question D. Answer D. If R is 0.74, R will continue to be 0.74. So I'm going to write R stays the same when we flip X and Y. Now, the one part that doesn't stay the same is the slope. The slope would still remain positive, but might get a little bit steeper if we flipped it. Notice if we flipped it, and you can kind of see through, it looks like it got a little steeper. Again, if I flip it back, it's a little less steep. So the slope might change, but R doesn't. Last question, another two quantitative variable question. So when we see a formula like this, or a printout rather, there's a lot of information they're giving us right off the bat. The intercept is our letter A in our formula, and the slope, in stats we call that B, the slope is right there. So that's our formula. You can also think of that as this is the label or the units for X. So it's pretty easy to put together a formula right off of a printout like this. I'm just going to put y hat is equal to a plus bx. And again, pulling it right off the chart, y hat, I'm going to have to read the problem. A is right there, plus b is right there, and that's my x. So looking through the problem, right off the bat, I can eliminate all of these that don't have a slope of 0.13. So I'm going to go ahead and do that. So now I'm down to these three, and I notice A is negative, so I need A to be negative, so it has to be letter B. Now you'd miss points if you actually listed this, because you would need to define what y hat is. So I am going to go ahead and read the equation. If this was a free response question, we'd have to say, well, what am I predicting? So it says, we're using this printout to predict wrist circumference. So technically, the best way to do this would say wrist circumference, hat, is equal to negative 2.13 plus the slope times my height. Notice both are quantitative variables because both have a unit of measure. Thanks for joining.